Hello friends, today I am starting my new tutorial on quadratic equations. That's right, so let's go. Quadratic equations. Okay, this is a very important topic regarding JEE mains and also +1 +2. So let's start. Anything of the form ax square plus bx plus c equal to 0 is called a quadratic equations. The reason it is called the quadratic equation because the highest power is 2. The highest power is 2. Okay? And what we want to see is we want the roots of the quadratic equation, means what does x is equal to, and by some analytical methods and some things the x turns to be as minus b plus minus b square minus 4ac upon 2a. Here are two roots because here there is plus minus, so minus b plus this one and one is minus b minus this one by 2a. Okay, this is a very important topic and I will highlight it by a red color mark. Okay, so let's go. Now this is quadratic equation. Now okay, this is the roots, and here before means finding out what are the actual roots, we will find first the nature of the roots. And to find the nature of the roots we need the discriminant. What is the discriminant? B square minus 4ac. Here b square minus 4ac, b square minus 4ac, this is the discriminant. And if b square minus 4ac is greater than 0, discriminant we denote it by d also, so we can write this one as d. So the roots are real and distinct. If d, which is the discriminant, is equal to 0, then the roots are real and equal. Alright, we have to go by the discriminant. Discriminant is a very important thing which tells us the nature of the roots of the quadratic equations. And if the third case is if d is less than 0, then roots are imaginary. Alright, okay. Before moving on further, let me show you some important results regarding the quadratic equation. We see if alpha and beta are the two roots of quadratic equation, then alpha plus beta is equal to minus b by a. Okay, and alpha into beta is equal to c by a. These are very important results. You need to remember these things. Alpha plus beta, which is the sum of the roots, is equal to minus b by a, and product of the roots is equal to c by a. Okay, another result which is not so very important but you can derive it anytime you want. Modulus means the absolute value of difference of the two roots is equal to discriminant, root of the discriminant by mod a, depending upon the value of a. Okay, now let's see, means if alpha and beta are the roots, then the quadratic equation can be written as x minus alpha into x minus beta equal to 0. Alright, which when we break it, x square minus alpha plus beta times x plus alpha into beta. So if you know the sum of the roots and the product of the roots, you can directly write the quadratic equations. Which is very easy. And again, one reminder, there is one important thing. If the roots are irrational, like of the form p plus root q, if one of the root is this, then another root will be, or I must suppose must be, p minus root q, because these irrational roots are always in conjugate. Okay students, always remember they are conjugate. Alright, now let's see again. If let's see another one. If the roots are imaginary of the form a minus iota b, then another root will be a plus iota b. Okay, this two important thing. Which one? I just said this imaginary conjugate one. This conjugate one is very important, and this thing, the imaginary thing, is very, very important regarding the quadratic equations. Okay, now some will see roots under particular cases. Number 1, if b equal to 0, then roots are equal in magnitude and opposite in sign. Okay, if b equal to 0, then roots are equal in magnitude and opposite in sign. Then number 2, if c equal to 0, what happens if c equal to 0? Then one root is 0 and other is minus b by a. Look students, you don't need to remember these tricks. Is just in JEE Mains the time is so short. In JEE Mains or any other competitive exams, I may suppose, like BITSET or VIEEE or anything. It can be anything. It can be a CAT exam also. In these exams, you need to be very fast in your work. So that you don't have to do and make the extensions all over again. If you remember, well and good. If you don't remember, no problem. You can still find it out. Alright? Okay. Now another special case. There are many other special cases which I am not going to discuss because they are not of so many uses. If a equal to c, then roots are reciprocal to each other. Alright, these are the special cases. Which you might find often. So 1 star for it. Alright, Now if I may suppose, if I tell you suppose that both the roots are common, okay, common roots. Students find really difficulty in finding the common roots. They find very hard to tackle them. So let suppose case one common root. Okay, one common root. The condition for common root, okay, like suppose alpha is the common root. Alpha is the common root. Alright, let me mark it out. Alpha is the common root. So I'm going to the next page. Remember, alpha is the common root. So the quadratic equation is ax square plus bx plus c equal to 0. Since alpha is one of the root, like suppose a1, b1, c1. Like alpha is the common root to this and this quadratic equation, a2x square plus b2x plus c2 is equal to 0. Okay, alpha is the common root to both the quadratic equation, so it will satisfy both the things. So it will satisfy both the equation. If we put alpha in place of x, then it will satisfy both the equation. So a1 alpha square plus b1 alpha plus c1 is equal to 0. Okay, and a2 alpha square plus b2 alpha plus c2 is equal to 0. Now let's remember one rule which have been studied, which you might have studied in class 9 or 10. In some boards they have, but in CBSE I don't know. I'm from a state board, so I don't know really. So the rule is what is called as Cramer's rule. In Cramer's rule, you arrange the things like alpha square, and the first coefficient like alpha, then it's a unity coefficient, then 1. Okay, then again alpha square. You write the coefficients like a1, then a2. You see, alpha square under alpha square, like a1, a2, in a1, a2, then alpha, b1, b2. See students, this is very important rule. C1, C2, C1, C2, they are constant terms. They are not having anything. They are not having anything in common. So they are constant terms. So they place in the unity part. Okay, like C1, C2. Again alpha square. You'll see why. You'll see it. Why I have done it like that? Because Cramer's rule stops here. I'm showing you one particular case so that you will not have any difficulty in writing the Cramer's rule. So alpha square, first one, then alpha, then unity. The Cramer's rule stops here, the Cramer rule stops here. This is a trick so that you can easily remember. Now when you write the denominator part of alpha square, alright, when you write the denominator part of alpha square, just cover it up. Cover the alpha square. What do you see? b1 c2, b2 c1. Okay, b1 c2 minus b2 c1. b1 c2 minus b2 c1. And when you write alpha, when you write the denominator part of alpha, just cover alpha. c1 a2, c2 a1. Very easy. c1 a2 minus c2 a1. Okay, like this. When you write the unity part, then cover it. a1 b2, a2 b1. Okay, now from this equation, what you find alpha? Alpha is c1 a2 minus c2 a1 upon a1 b2 minus a2 b1. And what is alpha square? Alpha square term says b1 c2 minus b2 c1 upon a1 b2 minus a2 b1. So here alpha, now putting the value of this alpha in this alpha square, you find the final summed up result. The final summed up result what we get is C1 A2 minus C2 A1 whole square is equal to A1 B2 minus A2 B1 multiplied times B1 C2 minus C2 B1, C1 B2, whatever you write it as. So this is the ultimate final condition of having one root in common. Having one root in common. So when you find one root in common, you just do like that. Okay, one root in common. All right. There's a condition for one root in common. So when you will think what will happen if I have both the roots common. Then the case is simpler than anything. Case 2, both roots common. Okay, when you have both the roots common, just have the ratio same. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. This is the most simpler case for all. The most simple case. Okay, students, what I have taught today is just a part of the lecture 1, so that you can quickly revise the quadratic equations as soon as possible for your boards as well as your competitive exams. If you find the video helpful for you, please like and subscribe it. Thank you. This is Professor D signing off to you, and this is my first lecture 1 on quadratic equation. Hope you find it enjoying. See you on the next lecture on quadratic 2, where we will discuss one of the most important thing. Students, please note, the most important thing, we'll see remainder theorem and working with inequalities in quadratic equation, which is the most challenging part. Students often get confused in these two parts. So in the next video we will show these two parts, and for by then, okay, see you in the next lecture. Thank you.